Zero molding is integrated technology for reducing loss, defects, and faults as near to zero as possible. Simple in setup, overall machine accuracy, stability, and productivity have also been improved. Zero molding consists of 3 separate technologies: MCM, FFC, and SPS. MCM, together with center press flatten and clamping force closed loop control, ensures best to mold clamping control. FFC controls resin flow during filling so as to ensure smooth, complete, and balanced cavity filling under optimized pressure. SPS is operability-related technology that facilitates setting work for MCM, FFC, and other features. So let us explain these technologies in the order of MCM, FFC, and SPS. The general idea with mold clamping force is to set it with ample clearance on the high side in order to prevent defects like burrs. However, if set too high, it can close vents, which prevents air and gas from escaping. This leads to short shots and burnings at the front end of the resin flow, where air accumulates and compresses. Mold deposits form quickly, which require frequent maintenance. Moreover, molds can be seriously damaged and last less time as a result. Furthermore, a high clamping force is not economical because it consumes more energy. So, let us take a look at the relationship between the position of the moving platen, clamping force, and the degree of vent closing. The mold clamping force is generated when the mold closes and the core and cavity halves touch for the first time. The parting faces become completely sealed. On the graph, it appears as an inflection point because from this point forward, the increase in the clamping force changes. Beyond this inflection point, the mold is pressurized and deforms internally. Thin vents become compressed, while air pockets become smaller. Once the clamping force gets beyond a certain point, air and gas do not readily escape, which results in defects like short shots and burnings. Moreover, because of the considerable deformation that occurs, the mold itself can be seriously damaged. In short, to ensure smooth filling, the clamping force must be set somewhere between the inflection point that marks when the parting faces seal and the tolerance limit where the vents become closed. Zero molding technology can detect the minimum clamping force required to seal the parting faces of the mounted mold. Just pressing a button on the touch panel starts automatic measurements, and 90 seconds later displays the results. With this value as the minimum, clamping force is lowered to the point that burrs do not form. Depending on the mold, molding can be done at 1/10 the maximum clamping force of the molding machine. To lower the clamping force requires both mechanical accuracy and precise movement control of the clamping mechanism. The center press platen evenly distributes the clamping force across the moving platen, whereby preventing pressure inconsistencies across mold surfaces. The double center press platen performs the same function on the stationary platen. Therefore, the surface pressure is more evenly distributed. A high-precision platen support mechanism supports the moving platen to a high degree of accuracy via a linear guide in order to prevent changes to platen coplanarity when molds are mounted. even heavy molds can be closed without sacrificing the high degree of coplanarity. A high-precision nozzle touch mechanism prevents the stationary platen from tilting under nozzle contact. During mass production, clamping force can fluctuate because of expansion caused by the heat of the mold. However, it is kept constant by feedback control that measures clamping force in real time via a sensor installed on the tie bar. In addition to these features, there is also a high-performance servo control mechanism and a highly rigid frame that minimizes vibrations held to reduce clamping force. To fill cavities completely, one idea is to chase the resin with a high filling pressure. Filling at high pressure can cause burrs in cavities near runners and gates. Moreover, a high clamping force is needed to push back against the high resin pressure, but this can result in clogged vents, which makes filling even harder. Ideally, cavities that function as vents fill smoothly without stress at low pressure. This animation compares typical resin filling and filling by FFC. FFC fills about 90% of the resin before the VP changeover point, then carefully fills the remainder during the set flash time using the viscosity of the resin. Filling is well balanced amongst cavities without short shots, burrs, or requiring a high filling pressure. Let's compare the waveforms. When flash time is set, it is seen how the screw position is controlled during that time. The waveform of the detected holding pressure dips slightly because of this. Cavities are filled with resin during this time. Let's watch and compare here what actually goes on inside the mold. These images were captured by a high-speed video camera that was set up to visualize the mold. Black powder was mixed in with the resin so as to follow the flow. In ordinary molding, flow front speed of the resin suddenly shoots up just before the tail end cavities are completely filled, hence losing pressure applied to the screw. As a result, the internal pressure is unbalanced amongst the four cavities with non-equidistant runners. FFC does not increase front flow speed, so the internal pressure is balanced amongst the four cavities, which means filling is balanced. FFC nimbly controls the speed and pressure before and after the VP changeover point. This high-tech solution is based on a direct drive servo motor of high response and operation precision, which is coupled to a servo control system that runs on a proprietary algorithm. This video has separately presented the MCM and FFC, but these two technologies are interdependent and demanding of one another. In other words, filling pressure has to be reduced to lower mold clamping pressure, and the clamping pressure has to be kept low to ensure proper venting and smooth, burr-free filling at low filling pressure. The technologies for mold clamping and filling are very mature and come via the pursuit of ideal molding, which is zero molding. SPS is operability-related technology that optimizes the interface. This newly developed NC10 controller adopts a large 15-inch full-touch panel. It is designed with an emphasis on intuitive operation, with wide use of pictograms for instantly identifying and discerning buttons. Screens are selected for individual operations from the Z main screen. Screens are laid out to enable easy operation, from setup to pre-production checks, even without knowing detailed procedures. Let's look at the mold mounting screen as an example. By simply following steps 1 through 6 on the screen, you do not have to be a seasoned engineer to safely, accurately, and fully complete settings. If we compare the actual setting operations from conditions input to purging against a conventional controller, we find 1/3 less buttons are pressed. And if we include also the number of screen changes and operation time, operation requires about 2/3 the work and time. Moreover, on-screen content can be customized according to purpose and managed between engineers and operators using passwords. SPS makes it possible to fully use MCM and FFC without ever consciously thinking about the difficulty involved. MCM for high precision clamping at low force. FFC for smooth, complete, and balanced cavity filling under low pressure. And SPS setting for simple, mistake-free setup. Zero molding is revolutionizing molding technologies and production efficiency by reducing loss, defects, and faults as close to zero as possible. See it for yourself in the operating guide video.